Hello friends, my name is Tushar and today I'm going to talk about stock buy-sell question. So you're given stock prices on certain days. You have to maximize profit by doing at max K transactions. So you can buy and sell at max K times. Also, these transactions cannot happen in parallel, so one transaction needs to end before starting another transaction. There are two more variations to this question. One is you can do at max one transaction. The other one is you can do as many transactions as you like. And the solutions for both those questions are much simpler than this question. This question requires dynamic programming solution. So first, let's look at the strategy for dynamic programming before looking at an actual example. Here, we are going to fill up our table T in the bottom-up manner. Here, the rows are my transaction and columns are my days. So for Tij, where I is the total number of transactions and j is the jth day, the value will be max of by not transacting at all on the jth day. So that value will be T of I, j minus 1, because we are not transacting at all at the jth day. So the value on the left, or the best you can get by completing a transaction on the jth day. So to complete a transaction on the jth day, it means that you have to sell on the jth day. So if you're selling on the jth day, it means that you have to buy on one of the days before jth day. So let's say that day was M. So the value you can get is price of j minus price of M, because you're buying at price M and selling at jth day. So price of j minus price of M plus T of I minus 1M. Why T of I minus 1M? Because here we have total I transaction. It takes one transaction to buy at M and sell at J. So we are left with I minus 1 transactions. And we have to finish this I minus 1 transactions till the mth day, because we are going to buy again at the mth day to sell on the jth day. So this value will give you the value you can get by buying at mth day and selling at jth day with total I transactions. So M here will go from 0 to j minus 1. So either this value or by not transacting at all on the jth day, which is this value, will give you T of Ij. So let's apply this strategy on a concrete example. In this example here, our K is 3, so you can do at max 3 transactions. And these are the prices going from 0th day till 7th day. And our aim is to find out the maximum profit. So our 0th row is all going to be 0, because no matter what the prices are, if you cannot transact at all, if you have 0 transactions, you cannot make any profit. Also, the 0th column is all 0, because no matter how many transactions you have, if you have just price for one day, you cannot make any profit. So next, let's try to find out the value at this cell here. So one transaction and day 1. So using this formula here, so first is what is the what is the best you can do by not transacting at all on the date 1. So that is this value 0. So maximum of either 0 or trying all the m's, all the days going from 0 till j minus 1. So in this case, there can only be one M, so M equal to 0. In this case, you are buying on the 0th day, selling on the 1st day. So that profit is 5 minus 2 plus whatever best you can do with one less transaction and ending that transaction at M. So with one less transaction, I minus 1, and ending that transaction at 0th day, so that value is 0. So maximum of these two is 3. So this value here is 3. Let's move on to one transaction and day 2. So again, what the best you can do by not transacting at all on the date 2, so that is 3. So 3, or trying M going from 0 till j minus 1. So M going from 0 to 1. So either M equal to 0 or M equal to 1. So if M equal to 0, the profit you can make by selling at 7 will be 7 minus buying at the 0th day 2 plus with one less transaction and finishing that at the 0th day will be 0, or buying at 5 and selling at price 7, so 7 minus 5 plus with doing one less transaction and finishing that transaction at 5, so that value here is 0, so 0. So maximum of these 3, so maximum of this 3 will be this 5, 7 minus 2, so this 5. So now let's solve for one transaction and day 3. So in this case, what is the best you can do by not transacting at all on the 3rd day? So that value is 5. So this value is 5. Or trying all the days going from 0 to 2. So if you are transacting on the 0th day, so this value here will be, so you're selling on the day, you're selling on 3rd day, so 1, and you're buying at a higher price, so 2, so 1 minus 2 plus 0, or 1 minus 5 plus 0, or 1 minus 7 plus 0. In this case, this value 5 is going to be best, so this value again becomes 5. Let's solve for day 4. So on day 4, the best you can do by not including day 4 at all is 5, so this 5, or trying all the values of m going from 0 till 3. So if you bought on date 0 and sold on the date 4, the profit you'll make is 4 minus 2 plus this 0. Or if you bought on day 1, so 4 minus 5 plus 0. Or you bought on day 2, so 4 minus 7 plus 0. Or you bought on day 3, so 4 minus 1 plus 0. So the maximum of this will again be 5. So this value also will be 5. So you can keep filling the table till the end of the row and all the values will be 5. So this is how we fill the first row. Next, let's fill remaining of the rows. Now the value of I is 2, so we have total 2 transactions. So again, starting with the 2 transaction and day 1. So one is, what is the best you can do by not doing transaction at all on the day 1, so that is 0. Or what is the best you can do by doing transaction by selling on day 1 and buying at day 0. So 5 minus 2 plus with one less transaction and finishing that transaction on the 0th day, so that value is here 0, so plus 0. So this value again is 3, so this becomes 3. So no, even if you have 2 transactions, you can still make 3 profit because you just have 2 days worth of data. So let's try for 7. So the best you can do by not transacting at all on the date 2, so that value is 3, or by trying M0 or M1, so by buying at either M0 or M1. If you buy at M0, it means that you are making a profit of 7 minus 2, so price of bought at 2 and sold at 7, so 7 minus 2 plus whatever profit you can make with one less transaction and ending that transaction at 2. So that value at the 0th day, so that value is 0. So this is 0. And with M1, it will be 7 minus 5 plus ending that transaction on the date 1. So that value here is 3. So this value here is 5 and this value also here is 5. So you can make a total profit of 5. So either you buy on the first day, sell on the second day, so that will make you a profit of 3, and then buy on the second day and sell on the third day, so that will make you a profit of 2, giving you a total profit of 5 since you have 2 transactions. Or you can just do one transaction, which will be buying on the 0th day and selling on the second day and making a total profit of 5, which is why both of them came out to be 5. So let's do day 3. So if we have day 3, it means our M can go from 0 to 2. So one is, what is the best you can do by not transacting at all at the day 3, so that is 5. Or your M, with M0, you're buying at 2 and selling at price 1, so 1 minus 2 plus not transacting at all and plus with one less transaction and ending the transaction, so that value is 0. Or with M1, so 1 minus 5 plus ending with one less transaction and ending the transaction at 1, so that value is 3. Or 1 minus 7 plus whatever best you can get by with one less transaction and ending the transaction at 7, so that's 5. So the max of this is going to be 5, so this value is 5. Okay, let's pick one, day 4. So with day 4, either the best you can do by not transacting at all at the day 4, so that value is 5, or M going from 0 till 3. So if you sell on price 4, so 4 minus, if you buy at 0th day, so 2, plus best you can do without with one less transaction ending at 2, which will be 0, or 4 minus 5, so 4 minus 5 plus this value 3, so this will be 3, or 4 minus 7 plus this value 5, or 4 minus 1, if M is equal to 3, it means that you are buying at the 3rd day, selling on the 4th day, making you a profit of 4 minus 1, plus whatever the best you can do by with one less transaction, and that transaction ending at the nth day, which is 5. So here this value is going to be the maximum, which is 3 plus 5, 8. So this value becomes 8. Again, here we will be, the way we got this 8 was, we buy at price 1 and sell at price 4, so that gives us a total profit of 3. And with one less transaction, we already know we can make a profit of 5 till day 3, till the price 1. So that value 5 plus this profit 3 is total 8, total profit of 8. So now our day becomes 5th. So our M will go from 0 to 4. So doing this very quickly, so this will be 3 minus 2 plus 0, or 3 minus 5 plus 3, or 3 minus 7 plus 5, or 3 minus, and this value is 8, 3 minus 7 plus 5, or 3 minus 1 plus 5, or 3 minus 4 plus 5. So here our best bet is this value 8, which is basically saying not transacting at all on the 3rd day, and take whatever the best you can do without, by not transacting at all on the 5th day, and take whatever the best you can do till 4th day. So that value is 8. And if you continue doing this, the best you will able to do will be 8. So finally, let's fill up this last row, and let's look at another optimization in which you don't have to look back all the values of M, but you can just do that in a constant time. So let's fill up the last row with this formula here. What happens with this formula is we don't have to look back M from 0 to j minus 1 and see which is the best day to buy. We can calculate that in a constant time. So let me explain this with the help of example, because this is pretty complicated. The first part of the formula, so T of ij is max of T ij minus 1, is pretty much same. So by basically not transacting at all on the jth day, so best you can do by not transacting at all on jth day, or price of j plus max diff, where max diff is max of current max diff and T of I minus j minus price of j. So let me try to explain you with this example. So let's go back to the time where our I was 2 and j was 3. So I was 2 and j was 3. So basically this point here. So to get this, what we did was we tried M using this old formula. We tried M0 to 2. So M0 to 2, and in there we set price of j minus price of M plus T of I minus 1 M, because we were selling at price j, buying at price M, plus the best we could have done by not run with one less transaction, so T of I minus 1 till nth day. So this is exactly that. this is T I minus 1 M. This is price of M because we are buying here, and this is price of 3 which is selling here. So this part here is a constant in this formula. So basically the max here will depend on max of this, this or this. So now when we moved on to the J4 with the same number of transactions, we again had this formula. Again here, this part is constant. So our max depend on the max of this, this, this or this. So now if we had kept the max of these three guys, so let's say this was the max, let's say this guy was the max of these three guys. So if we had this max, and then, so among these three, this is the max, and then we check this with this and find the new max and add that max to the price 4, we could have directly gotten the best we can do with J4I2 without looking back all the values here. So looking at this example here, for day 4 and 2 transactions, to get this 8, what I would be looking for is the difference from 0 to 2, so 0 minus 2, or the difference 3 minus 5, or the difference 5 minus 7, or the difference 5 minus 1. So max of this, so which is 4, this 5 minus 1, plus price of j, which is 4, is also 8. So again, max of these, which is this, plus price of 4, which is 4, which is 8, which is what we got last time as well. So if we kept this max, we do not have to go back in M, but we can directly use this formula. So I don't know if you understand that or not, but let's fill up the last row using this max diff. So now we're going to fill up this particular cell as per our new formula. So our initial max diff will be 0 minus 2. So our initial max diff is minus 2. So now using this new formula, the value here will either be the max of Ti minus 1, so this value, so basically not transacting at all on this day, so 0, or the price on this day, so 5 plus minus 2, so this value will be 3. So this value here is again 3. Now we try to go to the next day, so we are trying to fill up this cell. Before we fill up this cell, we'll have to recalculate the max diff, and to do that we'll use this formula. So max diff will be minus 2, so current max diff, or this, if we are filling this cell, then 3 minus 5, so that is also minus 2, so our max diff stays minus 2. So now our new max for this cell will be the max of not transacting at all on this day, so 3, or 7 plus minus 2, which is the max diff, so this value is 5, so this becomes 5. Again, before moving on to the next cell, we are again going to recalculate the max diff. So the max diff will be current max diff minus 2, or if we are going to go on this cell, then 5 minus 7, so that's also minus 2. So minus 2 minus 2 is minus 2. So max of minus 2 and minus 2 is minus 2. So max diff stays the same. Again, we are going to come to this cell. So to fill up this cell, we are going to say price at day 3, so 1 plus max diff, so minus 2, or not transacting at all on this day, so that value is 5. So this value becomes 5, which is the value from the left. Let's come to this day. Before going on to that day, let's recalculate the max diff. So again, the max diff will be current max diff minus 2 and 5 minus 1, 4. So now max of minus 2 and 4 is 4. So our max diff now becomes 4. So now let's come to this point here. So in here, our max will be by not transacting at all on the day 4, so that value is 5, or the price at day 4, so that 4 plus this max diff, which is 4, so this total becomes 8. Again, before going on to the next guy, we are going to recalculate the max diff. So the new max diff will be either the max of the current max diff or 8 minus 4, so that value is also 4, so max diff stays 4. So here, for filling up this cell, the max of 8, so max of 8 and max diff, so 4 plus the price of this item, so 3. So this value is 7 and this value is 8, so this again stays 8. And the max diff again will be whatever is the current max diff, so 4 or this 8 minus 3, 5. So our new max diff now will become 5. So now let's fill up this cell. So to fill up this cell, we'll say max of either 8, which is this value, or the price there, so 1 plus this max diff 5, so this value is 6, so this value stays 8. And let's recalculate the max diff before moving on. So the new max diff will be current max diff, which is 5, or the price here 8 minus 1, which is 7. So the new max diff will become 7. Finally, let's fill up this particular cell. So for this guy, the best you can do without transacting on the day 7, so that will be max of 8, which is this value, or the price here, so 3 plus this max diff 7, so this value is 10. So the profit here will be 10. So this is the maximum profit we can get with these prices and these many transactions. Finally, before looking at the code, let's see how we find out the days on which the transaction to do to get this profit. Let's retrace our steps back and try to find out how we got this maximum profit 10. So basically on what day we should buy and sell. So this 10 is not coming from this 8, which means that there is a transaction completing at this point, so we are selling on day 7. So sell on day 7. So if we sold on day 7, the total profit here is 10. We get a profit of 3 by selling on day 7, so we are left with 7. So basically, how do we get the remaining 7 profit? So since we did one transaction on this day, we are going to look at the row above it and see how do we get a difference of 7. So this 8 minus 3 is 5. This 8 minus 1 is 7. So this is the place, day 6 is the place where which we buy the stock. So buy on day 6. So now we are looking at this day and we are trying to figure out where is this 8 coming from. So 8 is coming from here, this 8 is coming from here, this 8 is not coming from here. Which means that we are doing a transaction on this day. So we are selling on day 4. So sell on day 4. And now we are trying to see where is this, on what day are we buying. So 8 minus 4 is 4. So we are looking for a place which gives us a difference of 4. So on the row above it, we are looking for 5 minus 4 is 1. 5 minus 1 is 4. So this is the day where we are buying the stock. So buy on day 3. Now this 5 is coming from here. This 5 is not coming from here. So 5 minus 7 is minus 2. So now we are looking for a place where we get this minus 2 difference on the row above it. So 0 minus 7 is minus 7, 0 minus 5 is minus 5, 0 minus 2 is minus 2. So we sell on this day, so day 2. And we got this minus 2 here at 0 minus 2, so we buy on day 0. So if we bought on day 0, that takes minus 2. Then if we sell on day 2, so that gives us a profit of plus 5. If we buy on day 3, so that takes minus 1 away. If we sell on day 4, that gives us a profit of plus 4. If we buy on day 6, that takes away minus 1, and this gives us a profit of plus 3. So the total here is 3 minus 1, 2, 2 plus 4, 6, minus 1, 5, plus 5, 12. Profit on day 2 is 7. So again, 3 minus 1 is 2, 2 plus 4 is 6, 6 minus 1 is 5, 5 plus 7 is 12, 12 minus 2 is 10. So these are the transactions you should do to get this profit 10. Let's analyze the time and space complexity. Space complexity is very simple. O of days into K. Time complexity also is exactly same. If we are using the new formula, time complexity is also going to be O of days into K. If you use the old formula, the time complexity will be O of days square into K. And with the new formula, the time complexity will be O of days into K. Also, remember, if K is going to be greater than days, it's not going to increase the profit anymore. So in the worst case, K can be as good as days. So in worst case, this will be O of days, total number of days you have, into square. So next, let's look at the code for this algorithm. If you understand the logic, the code is extremely simple. First, let's look at the max profit slow solution, where we are looking for the M at which we should buy to sell at the jth day. So it takes in the prices, it takes in the total number of transactions. We initialize our T. Our I goes from 1 till the total number of transactions we have. Our J goes from 1 till the total number of prices or days we have. Then our max value initially is 0. We have our I go from 0 till J minus 1, and then max value is max of the current max value, and then prices of J minus prices of M plus T of I minus 1 M. So basically, since we are selling at price J, so price J minus buying at price M plus the best you can do with one less transaction and till M days. And then finally your T of I J will be max of T of I J minus 1. Basically the best you can do by not executing transaction at the jth day, and the max value which we found above. And then return T of K price dot length minus 1, which is the bottom right corner in the two-dimensional matrix. Let's look at the max profit, the faster solution. Again, your initialize your T. I goes from 1 till total number of transactions. Max diff initially is minus price of 0. Then J goes from 1 till the total number of days we have. T of ij is max of T of ij minus 1. So again, as before, the best you can do by not executing any transaction on the jth day, and max of that, or price of j plus max diff, where max diff is a max of max diff or the current max diff, or T of I minus 1 j minus prices of j, as we discussed before in the video. And in the end, again, you return T of K prices dot length minus 1. I also have this method print actual solution if you want to actually print at what price we should buy and sell. Let's quickly run this code. So the max you can get, so the max profit you can make is 10, as we had before in the video. Also, so this is all I have to talk about this problem. The link to this code is in the description section of the video. I also have a Python code for viewers who are interested in Python. Please like this video, share this video, comment on this video, check out my Facebook page, and check out my GitHub link. Thanks again for watching this video.